Cool. You want to show the customers what it's all about?
Sure, let's open it up. So what you see in each rack there basically is that you see that each rack can have up to 80 trays. Each tray can have 2 server nodes in there, and each server node can have 2 processors. So it goes up to 320 processors per rack. So that's quite a density.
How do you support the power required by these servers?
So the only way you can build such a dense system, you need to bring in 480 AC into the system.
Okay.
Otherwise, at 208, that would be wires that are way too big, and on the amp side, that would be quite complicated.
Does it cost more to bring that in?
It's actually cheaper.
How many of those 10 kilowatt rectifiers do you have in this rack?
There's 8 of those.
Okay.
And basically, they're all built to have a redundant model. So depending on the redundancy you want, you can have up to 80 kilowatt of power in the rack. You have the management module here. We aggregate all of the ILO sensors. That system is instrumented like crazy. We monitor the temperatures, the water temperatures, the flow rate, the whole shebang.
ILO 4, SLA PM2 support,
you
all
got
figured out
all
in
of
that 6U
and
utility
basically
module.
it comes out from one wire. Instead of having 160 wires coming out of 4 racks, you have one wire with all of your management coming out of it.
Cool.
What you also get, we're not showing it on this rack, but these 2 slots are basically to have integrated Ethernet switching built in the rack, and we're also working on the integration of InfiniBand. So it's really a supercomputing platform with everything built in.
Okay. And you want to talk about our secret sauce around how we differentiate with our liquid-cooled dry disconnect technology?
This is it. Servicing a water-cooled node is as easy as disengaging the thermal bus bar, disengage the IT and the power, and pull out that tray. And what you see right here is that dry disconnect system, and that's the thermal transfer technology for that tray. What you see in that tray basically are 2 component level liquid cool servers. Each of them is fully independent, so there's the front one and the rear one.
But there's no water in the server.
Well, that's interesting, because basically it's a water-cooled system with component-level liquid cooling for both the processors, the memory, but with technically no water in the tray.
Wow.
And the way we do that is by using those heat pipes. They transfer the heat from the processor all the way to that dry disconnect, and that's where the heat gets captured and transferred into the water wall that's in the rack, and that goes to the facility.
You want to talk about the I/O for the servers and also the power capabilities of the tray?
So the power capability, that power supply basically takes that high voltage DC I was just talking about, and then distributes it to the 2 nodes in the tray.
Okay.
That goes up to 1200 watts.
Okay.
And then you can add an SSD on each server, and that's actually our InfiniBand HCA, which is probably the smallest in the world. At 80 trays per rack, you can basically build an exascale system in a footprint that's much smaller than pretty much anything else. What's also really interesting of the partnership we had with NREL is that not only this rack is warm water cooled, so you can feed this rack with 30C water and get the full performance, but we're also using it as a furnace for NREL.
Okay.
Meaning that since September, that system has been eating the whole ESIF building, because even when it's idling, it will make 35C water. When you're putting load on it, it makes even higher than that. So we actually over-delivered on NREL requirement there.
From an efficiency perspective.
And from an ability to create hot water, even when the system is doing nothing.
So NREL is using the heat coming out of this platform in the deployment to heat its sidewalks, to supply heat to its facility areas?
So the first step is to heat the building.
Okay.
And then if there's remaining what we call waste heat, but unfortunately with those platforms, it's just energy that we recapture. That's being sent to do snow meltings, for instance, for safety on the sidewalls and things like that.
Wow.
So, Rajiv, to show the folks, let's see how easy it is to put back in one of those nodes.
You want me to try it?
Yeah, do it for the first time.
Okay. All right, let's see. Okay.
So you push the black thing, and then you engage the dry disconnect.
All right.
And boom, that's it. Wow, if a marketing guy can do it that fast, pretty much any HPC geek can do it
I
pretty
did only
quickly.
10 seconds.
That's pretty good.
Liquid-cooled servers, but we wanted to make serviceability and replacement as easy as air-cooled servers. All right, let's see the cooling distribution unit.
All right, so part of the ecosystem for this platform it's not only the IT rack, it also comes with a supporting infrastructure rack that has the coolant distribution unit in the bottom, and then some rack space to go put the switches and other equipment supporting the whole HPC infrastructure. So the key thing about the CDU is that it isolates the facility's primary water with the IT loop, from the IT loop. Why do you want to do that? Well, water quality aspects and all of those things. Not that we require any exotic water on the secondary side. We don't require deionized water. We don't require distilled water. Basically, any ASHRAE spec water pretty much rolls into the system.
And is an ASHRAE spec water readily available in the data center?
Well, here at NREL, their tap water is ASHRAE spec, so we just filled it with a garden hose, and it worked pretty easily.
What about our other customers? How would they?
Well, it all depends. Worldwide, the water quality is different. So in some countries, we'd have to do some.
But we don't need treated water. We could use an ASHRAE standard water.
Yeah.
We have our own filtration that sort of.
We'll show you that downstairs, but there's filters on every rack.
Okay.
And basically, the CDU is capable of 320 kilowatts of cooling.
Okay.
So that's 4 80 kilowatt racks or more racks if it's less than 80 kilowatts.
Okay.
And the key aspect in this is that not only it has a positive displacement pump in it, but it also has a vacuum pump. Why do you care? Well, by having a vacuum pump, it means that we're running the secondary side. The secondary side is the water that flows through the racks out of a vacuum. So if in any circumstance, any pipe was to come loose for whatsoever reason, instead of dropping water, we'd be sucking in air, and then we can automatically detect it very fast with a bubbler and basically alarm that we might have a leak somewhere.
Key piece of our technology here, we're basically making sure that the nervousness around the liquid-cooled technologies in the data center that customers have around, water leakages. You're saying HP has a way to sort of mitigate that risk, ensuring that there's no leakage. We're talking about that secret
So basically,
sauce.
not only we have the dry disconnect, which we believe is actually much safer from a water leak perspective than anything else out there, but on top of that, we run the secondary loop out of a vacuum.